This is NSAA 2021, Section 1, Question 16. So we have two right-angled triangles that have the same length hypotenuse, which I've labelled H here. So we have one right-angled triangle here with an angle of 45 degrees and a length here of y, and another one here with an angle of 60 degrees at the top and x along the bottom. And we have to find an expression for y in terms of x. So how are we going to go about doing this? Well, we know they both have the same length hypotenuse, so if we get, say, y in terms of h and x in terms of h, we can use that to substitute in the equations to find y for x. So let's find, for this first triangle, an expression for y in terms of h. Now, we have a right-angled triangle here, so probably going to suggest we need to use a bit of trigonometry. So what trigonometric function are we going to need here? Well, we can see we've got the opposite from the angle and we've got the hypotenuse, and that's going to suggest to us that we need to use the sine function. So if we substitute that in, we have sine 45 with our opposite being y and our hypotenuse being h, so sine 45 equals y over h. And if we rearrange for h, we're going to get h equals y over sine 45. And if we do the same thing for this triangle, here again we can see we've got the opposite and the hypotenuse, so we need sine 60 equals x over h. If we rearrange for h, we get h equals x over sine 60. Now we can make these two equations equal to each other as they both are equal to h, and we get y over sine 45 equals x over sine 60. And if we rearrange just to get y, that's what our question asks us to do, we're going to get y equals x sine 45, as we've times this equation by sine 45, all over sine 60. Now this is the correct answer, but we can simplify this more using our trigonometry rules. So here's our expression again, I've just written it out, and we want to try and find what are the numerical values of sine 45 and sine 60. Now if you don't remember these, we can use the trigonometry triangles to work out what these values are. So if we start with sine 45, the triangle to help work this out is going to be a right angle triangle with an angle of 45 here and two side lengths 1. We can find the hypotenuse by using Pythagoras, so 1 squared plus 1 squared equals 2, and so the square root of that is going to be root 2, so that's our hypotenuse length. And for our sine 60, we can use an equilateral triangle, so every angle is 60 degrees and every side length is 2. If we split up this in half, we can work out this length by using Pythagoras, and that's going to be root 3. And now we can use these triangles to work out these values. So our sine 45, we want the opposite over the hypotenuse, so that's 1 over root 2. And to simplify this, we don't really want a third on the denominator. So if we times both the top and the bottom by root 2 to sort of simplify that out, we get root 2 over 2. And for our sine 60, if we go to this triangle, again we want our sine, so we want our opposite, which is our root 3, over a hypotenuse of 2, so that's just root 3 over 2. So now let's substitute these into our equation here. So we're going to get y equals x root 2 over 2 divided by root 3 over 2. And because we're dividing fractions here, we can make this an easier way to solve by just flipping this upside down and timesing them together. So we're going to get x root 2 divided by 2 times 2 over root 3. And if we simplify this down, we're going to times the top by the bottom. Actually, we can cancel out those 2's there, as they're both one on either side, so we can cancel those out to just get x root 2 over root 3. But again, we've got a third on the bottom here, which we don't really want. So if we times the top and the bottom by this root 3 to get rid of it, we're going to get an answer of x root 6 over 3. And that is our final answer. So our answer overall is G.